Good morning to everybody. My dear students, in my previous class, I have already discussed about the Arrhenius theory and Lowry Bronsted theory for acid and base. You please concentrate on this diagram. Diagram that is HCl gives H plus ion and Cl minus ion. Like this, it is one of the example for molecule. It is for ion H3O plus, H plus plus NO3 minus. It is for negative ion HSO4 minus, H plus plus SO4 minus minus. Like this. Bases are the substances which can accept a pair of one proton. Okay, NH3 plus H plus giving NH4 plus. CO3 minus minus accept one proton gives HCO3 minus ion, and H2O also accept one proton gives H3O plus ion, that is hydronium ion. But in my present class I want to explain you what are the limitations. That means though some substances behaves like an acid but does not give any H plus ion or proton to its aqueous solution. That means some limitations must be there. So we shall discuss the limitations of Arrhenius theory. As per Arrhenius theory, the substance even does not contain H plus ion or OH minus ion, they show the properties of acid and base. For example, water. Water accept H plus ion to give H3O plus ion, and some of the substances are there. If we consider only Arrhenius theory to be true, then it fails to explain the acidic and basic properties of some other solvents. In third point, it fails to explain the acidic nature of carbon dioxide, sulfur dioxide and P2O5. Okay, it also fails to explain the basic character of CaO, NH3, etc., which does not contain any OH minus ion, but it acts as one of the base. So these are the limitations. It also fails to explain the neutralization reaction of the substances which does not gives any water. As per the acid-base neutralization theory, acid reacts with base to give one salt and water. But if this calcium oxide is one of the salt plus sulfur dioxide, it only gives CaSO3. Okay. Similarly, ammonia is base and HCl is acid. It only gives NH4Cl, no water. That's why there are some limitations. Similarly, that Lowry Bronsted theory has some limitations. That is, if it fails to explain the reaction between acidic oxides such as CO2, SO2, NO2 and basic oxides such as CaO and BaO, MgO, etc. That's why what happens, the third theory arises. The third theory for acid and base is Lewis theory. Lewis states that an acid is defined as any substance that can accept a pair of electrons. While base is defined as any substance which can donate a pair of electrons. Okay, so we shall discuss one by one. First of all, Lewis acids. Lewis acids, all cations like Cu++, Ag+, Ca++, Fe++, all these are your Cu++ Ca plus plus, Fe plus plus, these are all Lewis acids. Second example is molecules having electron deficient atom. Examples are FeCl2, ZnCl2, AlCl3 and SO3, sulfur trioxide. If you concentrate in this, that means what is the meaning of your electron deficient atom. The atom number of SO3 is 16 and its molecular, your electronic arrangements are 1s2, 2s2, then 2p6, 3s2, 3p4. If I write in this manner, then this is 2p6, then 3s2, it is filled up. Next comes 3p4. So first of all of you know that single occupancy arises like this. Next electron goes to this place, but what about this place? This place remains vacant, and that's why it is known as this particular proton sulfur is having electron deficiency, and another 2 electron comes from your oxygen to fill up this. So as there is some electron deficiency, as per Lewis theory, it is one of the acid. Your third point is molecules having atoms which can accommodate more electrons in the d orbital. Examples are SiCl4 and SnCl4. SiF4, SN. Examples is SiCl4, SiF4. Silicon tetrachloride, silicon tetrafluoride, like this. In my next class, I will show you the particular diagram. And another example is there, molecules having bonds between atoms of different electronegativities. That is carbon dioxide, sulfur dioxide, like this. We shall discuss with electronic theory. And next is the examples of Lewis base. All negative ions, that means here all positive ions are Lewis acids. Similarly, all negative ions are Lewis base. Example is OH minus, Cn minus, then CS3, COO minus, like this. Why? It can accept a pair of electrons. It can accept a pair of electrons. And another example is neutral molecules having one or more than one lone pair of electrons. Example is NS3, water, and all alkyl amines. I will show you the diagram, that is for example nitrogen. Nitrogen contains 5 electrons in its outermost cell. As the electronic configuration, 7, your atomic number is 7, 1 is 2, 2 is 2, 2p, 3. Like this. And what happens? Actually, when one hydrogen comes in contact with nitrogen, and all of you know that hydrogen contains only one electron. So those one electron, they will accommodate here. Okay. These are the cross and dot product. As for cross and dot product, nitrogen contains 5 electrons like this in its outermost shell, and hydrogen when enters to these places, bond will occur between this, and this remains as lone pair. Lone pair means it doesn't make any bond with another atom nearer to it. That's why it has the capacity to donate a pair of electrons. That's why this ammonia, like that, water, and all alkylamines are treated as your Lewis base. And
ma'am, I have a doubt that the bond between nitrogen and hydrogen is what type of bond?
It is simply covalent bond, equal share pair. Nitrogen donate 1 electron, hydrogen donate 1 electron. Covalent bond. Why this water is treated as universal solvent? Because it has the capacity, that means as per Arrhenius theory, water acts as one acid. If we consider the Lowry Bronsted theory, then also it donates 1 proton, and as per this Lewis theory, what happens? It has the capacity to donate 2 lone pair of electrons. That means it is also acts as a base. How it is possible? Oxygen has got 6 electrons in its outermost shell, and individual hydrogen, when it comes to make bond, then they will form this covalent bond, equal share pair, and these 2 lone pair of electrons are there. So it acts as one of the Lewis base. That's why this water acts as an acid as per Arrhenius theory and Lowry Bronsted theory. But as per Lewis theory, it also donates a pair of 2 pair of electrons. That's why it acts as one of a universal solvent. Okay.